the density of 2 moles aqueous solution of NaOH. We have NaOH solution, given solution. Okay, so the density of this solution is how much? 1.28 gram per cc. Okay, the molality of this solution, the molality defined by capital M or small n? Small n. Of this solution is how much? Question mark. Okay, we have here, it's given the molecular mass of sodium hydroxide is how much? What is the parameter of molecular mass? The symbol parameter, molar mass, right? How much? M of NaOH. Aqueous, it means whenever the question is telling aqueous, it means water is the solvent. Okay, whenever an aqueous solution is there, water will always be the solvent. Okay, so we have here the solute is solute. Okay, let's put solvent. Solvent is water. This is A. Okay, and then solute, right? Solvent defined by A. Okay, and then solute, sodium hydroxide, NaOH. This is B. Okay, now this is the solution S. Okay, next we have here the molecular mass of solute or solvent, of solute, right? The molecular mass of solute is how much? Solute, A or B? B, right? Okay. Now it is, see, here we have this molar mass, which is the molecular mass, and this is the mass, which is the weight. Okay, there is a difference between these two. Okay, so now we have here M of B, right? Solute, we have how much? 40 gram per mole. Okay, next the question is asking about the molality of the solution. Molality of the solution here is given number of moles of the solute by weight of the solvent in kg. Okay, number of moles of the solute, number of moles of the solute by weight or mass of the solvent in kg. Okay, right? Now when we say mass of the solvent, it means mass of water, right? And here number of moles of the solute, it means number of moles of sodium hydroxide. Okay, so to find molality, we have to find number of moles of the solute and the mass of the solvent. Okay, so how to find this NB and WA? It is given here density. We have here density of the solution is Ws by Vs. Okay, density of the solution here, we have density of the solution is how much? Ws by, what is this Vs? Mass of the solution by volume of the solution. Okay, this is the density of the solution. So now this is the weight of solute, I mean of the solvent. This is the solution, this is the solvent A, this is the solute B. Okay, this is water and this is NaOH. Okay, next the mass of the solute, this whole mass is Ws, right? The mass of the solvent Wa, the mass of the solute Wb. Okay, so the mass of the solvent is equal to the mass of the solution minus the mass of the solute. Am I right? Huh? The mass of the solvent is equal to the mass of the solution minus the mass of the solute. We get the mass of the solvent, right? Why? Why we derive this one? Because we have mass of the solution. Okay? The mass of the solution we can find from here. Since the density is already given of the solution, so we need the mass of the solution. Okay? So now, here the density of the solution, we have to find the mass of the solution is how much? Density of the solution into Vs. Right? This Vs volume is given there. Mass of the solution is equal to density of the solution is equal to weight of the solution by volume of the solution in liter. Okay? This one, it is given in liter. Right? So this will be in liter. Okay? Next, density we have 1.28. Right? We have how much? 1.28 into volume. Volume we have here in liter, right? Per liter. Okay? So we have here 1 liter. Okay? But liter we have to convert to cubic centimeter, since the question is asking in terms of cc, right? So we have to convert this one. We get how much? 1.28 into 1 liter. I've given there 1 liter equals how much? 1000 cc, right? So we're getting here how much? 1000 cc. Okay, this will be the weight of the solution. So now we're getting weight of the solution, right? Right? But right? Okay. Now the weight of the solute. How to find the weight of the solute? Weight of the solute. Here we have the weight of the solute, right? The number of the solute equals to weight of the solute by mass of the solute, right? By molar mass. We have here number of moles of the solute is defined as the weight of the solute, right? By molar mass of the solute. Okay. Next, we have to find WS. We already got WS, right? So now we have to find WB. Okay, WB is how much? NB into NB. Okay. Next, NB, we have here the density of 2 mole. This 2 mole is of sodium hydroxide, right? What is this 2 mole? Is the number of moles. Okay. So it is given here. Number of moles. We get here how much? Number of moles of the solute is how much? 2 mole, right? Let's just put 2 mole. Okay. Now this one is how much? 2 mole, right? What is the molecular mass of the solute? Solute of B means molecular mass of NaOH. How much? Molecular mass of NaOH. Right? Molecular mass of NaOH. We have here NaOH, right? So we have here 111. Okay. Now, how much? Sodium, the mass of the sodium, how much? 23. So you have your 1 into 23 plus 1 into this one? 16. And then plus you have your 1 hydrogen atom into how much the mass? 1, right? How much we're getting here? 40, right? 40. What about the unit? What about the unit? Yeah, gram per mole. Okay, this is the molar mass of the solute, right? Okay, remember this molar mass is in the unit of gram per mole. Okay, or molecular mass means the mass of this molecule. Okay, we have the mass of sodium is 23. We have only 1 sodium atom, so 1 into 23, right? We have only 1 oxygen. The mass of 1 oxygen atom is 16 gram. 1 into 16, right? We have hydrogen atom, mass of hydrogen atom from periodic table is 1 gram, 1 into 1. Okay, suppose if we have here 2, it means 2 into 1, right? Next, we have 40, so here will be how much? 40. Okay, next, we already got WS, WB, and now we have to find what? This MS, right? MS, since we are getting WA, right? And NB also we are getting, right? Okay.